All right. If.
Holy cow.
What do you think a unit circle is, specifically? When you say unit.
It's
What's a unit of?
Well, if you say a unit, what do you think of first?
It's all one thing.
One. So like a unit of measurement is a meter. So if you talk about a meter, how many meters are you talking about? Just 1 meter. If you're talking about an inch, how many inches are you talking about? One. So when you talk about a unit circle, it's a circle that has a radius of 1.
Who knows?
Oh, okay.
And then it's just a circle centered at the origin.
Cool.
Did I draw it badly? Yeah, probably.
I was on this side angle.
Yeah, it just looks weird. So if you have a radius whose, a circle whose radius is 1, and you move the coordinate along the circle and open your angle up to theta.
Why are we talking in all these languages?
This is what trigonometry is all about.
I say the Greeks created trigonometry, didn't they?
Pretty much. And conic sections and a few
math.
other things. And math in
Torture.
general.
They also invented torture.
I bet torture was around years before that.
Well, they were fine.
Alright, so if you're on a unit circle and you open up an angle of theta, keeping this side on the terminal side of the positive x-axis, then the coordinate of this point, even though it's x comma y, where, do you know what the equation of a circle is? Equation of a circle, you should have learned that in 171.
Yeah, we did.
What is it? Pythagorean Theorem, literally. A squared plus b squared equals c squared, but a is
Pi. X. What?
He wants us to
Ready?
settle
Drop this
something.
down. It's a right angle, right? This side is,
Oh, no way. That's
this side is
It's X.
x, this side is,
Y.
and to find the other side you have to go x squared plus y squared equals,
C squared.
well in that case, 1. So the equation of the circle is x squared plus y squared is equal to 1. Pythagorean Theorem is where circles came from.
Will
Alright.
it always equal 1? Will it always equal 1?
If it's a unit circle.
Oh,
If it's a circle with radius 2, then it would be 4.
I thought that's where triangles.
R squared. Alright, so this is a unit circle. If we're a coordinate on the unit circle and we open the angle up to theta, then x is equal to cosine of theta, and y is equal to sine of theta. Now we're getting into more symbols.
Yay.
Aren't you excited?
I remember sine and cosine.
Okay. This is just what's called the unit circle definition of sine and cosine. And there's no rhyme or reason about it, it's just the way they're defined.
Have a button for that on the calculator too, thank you.
And there is a button for that on the calculator, but it only gives you approximate answers, and guess what I want?
Exact.
I love exact. For instance,
Exactly.
if you are on a unit circle, and this coordinate is 1, 0, what's this coordinate up here?
0, 1.
0, 1. This coordinate over here.
Negative 1, 0.
This coordinate down here.
0, negative 1.
This is one of the first pictures you draw on your test. This one right here, the circle with the 1, 0, 0, 1, negative 1, 0, 0, negative 1. Why? Because it is the only picture that allows you to find sines and cosines of 0, pi over 2, pi, 3 pi over 2, and 2 pi. No other picture will do it for you. Does that make sense? So if I'm asking a question like this, example, what is the sine of pi over 2? Well, what you think is you're on a unit circle, and you're at the top here. Pi over 2 would be this angle here, the right angle. What's the coordinate of this point? 0, 1. And which coordinate is represented by sine?
Y.
Y.
Since sine is equal to y, it's the y coordinate on a unit circle. Be careful, it has to be a unit circle. It can't be any others. So what is this equal to?
Is it 1?
It's 1. Because it's the second coordinate in that location. Alright, if I have cosine of pi, what's it equal to? Well, where's pi? In your unit circle, where is it? Pi.
Pi is 180, isn't
Uh-huh. So where is it in this
it?
picture?
So it's be negative 1.
It would be over here, right? So this coordinate is negative 1, 0.
So it's negative 1
So this is equal to negative 1.
because it's the x coordinate, right?
Because it's the x coordinate. Because cosine is x and x is negative 1. How about sine of 5 pi over 2.
Chart.
This is where counting comes in handy.
Yeah.
Up here, this is 1 pi over 2. If you go to the left, it's 2 pi over 2. If you go down, that's,
3 pi over
if you go one more, that's 4.
2. 5 pi over 2.
So it's at the top again.
So it's going to be 1 again.
It's going to be 1 again. Counting with pies is actually kind of easy.
The
Alright.
funny part is, but when you look at it, if you don't remember off the top of your head, it's hard.
Yeah. Well, that's the thing. You have to practice this.
You always start at the top.
You always start here.
That's 0.
That's 0. This would be pi over 2, pi, 3 pi over 2, 2 pi. And then you just kind of keep on going.
Okay.
Positive direction is counterclockwise. Negative direction is backwards. Clockwise.
Clockwise.
All right. Unit circle is okay for some things. For instance, a little strange math. Find sine and cosine of angle formed by y equals 2x and positive x-axis.
Wait, what?
Find the
Oh,
sine
okay.
and cosine of the angle formed by y equals 2x on the x-axis. Positive x-axis
X-axis.
to the right.
Yeah.
All right.
Holy Jesus.
So, best thing to do, draw a picture. I highly suggest you get the unit circle in here because that's the only thing you know so far. What else can I draw? Well, positive x-axis is there. Where's y equals 2x? How do you find y equals 2x? How do you draw it?
Well, y equals the sine of theta.
No, but how do I draw y equals 2x? How do you draw y equals 2x? Y equals mx plus b? What's m represent?
Float.
What's b represent?
The y was
What's the y-intercept of y equals 2x?
0.
0. So it goes through the origin. Yes! What's the slope?
It's 2.
So how do I draw 2 slope?
Every time you go up to, you go over 1.
Up 2 over 1. So if I go up 2 over 1, I can imagine that it's like right there. So this line would be
I
going...
thought that was a unit circle, though.
It is. But a line goes off forever in both directions.
If you went
Oh.
up 2 when you go past the circle.
I can go 1/2, and over a half. That's still a slope of 2.
Okay,
I can go up a tenth, and over a tenth.
yeah.
So I just went 1, 2, and made that.
So the 2 is actually 1.
Yeah.
Okay.
But the slashes still are the ratio 2, if that makes any sense. All right, so what I'm looking for is, here's my angle, theta, between the positive x-axis and the line. What's the only way of finding sine and cosine right now? To find sine and cosine for these 3 examples, I need to know the coordinate of the point on the unit circle. So I need to know the intersection point of this line and the circle. How do you find the intersection of a circle and a line?
You have to use x squared plus y squared.
X squared plus y squared is equal to 1.
Yeah, you have to use Pythagorean.
Well, it's the equation of the circle, not Pythagorean theorem yet. Well,
It's very similar to it.
That'd be messy and hard to do. What else do I know about this? I know the unit circle is x squared plus y squared is equal to 1. And I want to know where the line y equals 2x runs into this. So at that point, it's on the line and it's on the circle. So at that point, y is equal to 2x on this circle.
So you put 2x where y is.
So you put 2x where y is. So you get x squared plus something squared is equal to 1. And inside here goes 2x. All right. What's 2x all squared? I feel like I asked. What's 2x all squared?
Well, Joe, is it?
4x.
Thank you.
Squared.
4x
Squared.
squared. Okay. 4x squared equals 1.
And you combine them.
And you
Chug
get
along here.
5x squared.
5x squared is equal to 1.
And then you divide by 5.
And you get x squared is equal to a fifth.
And square root, so it's plus or minus.
But in that quadrant, it has to be
Plus.
plus. So it'd be plus.
Square root of 1/5.
Yeah, but that's illegal.
Square root of negative 5 equals 5.
Square root of 1/5. Square root of a fifth. But having a fraction in a radical is illegal. So
It's
how do you?
illegal?
It's illegal. You're not supposed to do it mathematically. So can you simplify it?
No, but I bet you can.
I bet you can too if you thought about it.
You could turn into a decimal.
No, I don't want a decimal.
Oh, dang it.
Split it.
Split it out.
Square root of the top, square root of the bottom.
Oh, square root of 1 and square root of 5.
And square root of 1 is
1.
over the square root of 5.
Square root of 5.
That's illegal. Can't have square roots in the
That's
bottom.
right.
So how do you simplify it?
Flip it.
How
You
you just
multiply
flip it?
multiply by the reciprocal. Right?
No, you're getting into conjugates. I don't want you getting into conjugates for something simple.
You do multiply something though, don't you?
To
You
make
multiply
the
by square root of
bottom-
5.
Hmm?
Multiply by the square root of 5.
Multiply top and bottom by the square root of 5. And what do you get out of that mess?
You're going to get 1 square root of 5 over 5.
So square root of 5 over 5. That's what x is equal to.
Okay.
What's y equal to?
2 times that.
2 times that. So it'd be 2 square root of 5 over 5. And if you don't know why it's 2 times that, you go back up to y equals 2 times x. Whew. All that just to get to one little thing.
You still have to find sine and cosine though.
You actually already did.
Really?
Kind of.
Kind of.
Which one's this?
Ah, right. That's right.
So what is the sine of theta equal to? It is the coordinate of a unit circle. Which coordinate?
Y.
It's the y coordinate. What's the y coordinate?
That's that.
It's that.
Oh, so that is the sine.
So sine of theta is 2 square roots of 5 over 5. What's cosine of theta?
Square root of 5 over 5.
Square root of 5 over 5.
Okay. I was making sure.
It makes it kind of easy. But it has to be on a unit circle. It cannot be on any other circle. Only works on a unit circle.
Time's running 10.
What?
Stop the time.
We started 5 minutes early too, don't forget that.
It's happy hour.
It did not.
It is happy hour though.
Yes, we did. Don't keep going.
Why?
Because this is so much, we still have to study for our test.
And this is boring stuff, though. That's why I wanted to get it out of the way.
I'm not more than you. Remember.
You see like a shit.
Special angles. For instance, pi over 4 on a unit circle.
Special angles.
Depending on how you want to do it, there's a couple different ways of doing it. If I draw my unit circle, and this is 1, 0, where would pi over 4 be in this really bad drawn picture? Where would the angle pi over 4 go?
1 second.
Oh, come on, pi over 4. Pi over 4.
It's 45 degrees.
So how do I draw it?
You just draw it.
It's half of that quadrant.
It's half of that quadrant. Ooh, I missed it. Dang it.
Oh no.
There we go. For you, I get to erase this. Up there, I can't. All right, so we're looking for this intersection. Now, we could do it that style where we just use the equation of a line, or well, is there another way of doing it? Not nicely. Actually, there is a nicer way, but I don't want to talk about it. So what's the equation of this line if it's pi over 4? And it cuts the quadrant equally. What's the only line that goes straight down the middle of the quadrant?
Y equals X.
Y equals X. So this coordinate here is Y equals, or I'm sorry, the equation of that line is Y equals X.
It's a 1-to-1 ratio, right?
1-to-1 ratio. So if I set up x squared plus y squared is equal to 1,
Y is going to be equal to X, so it's just X squared plus X squared.
x squared plus x squared is equal to 1.
So it's 2x squared equals 1. Square root of 1/2, but you can't do that.
Is that supposed to be x squared plus x
I
squared?
think it's a rest
Because
of
x
one
is
square
equal
root of
to
2 square root.
y. You know, we're up here. X is equal to y. So wherever I see a y, I can replace it with x.
So X is square root of 2 over 2.
Square root of 2 over 2.
See, I don't need no paper show work.
Yeah, great. Yeah, now if you get it wrong in your head, I just mark it wrong because there's no work to look at. I love giving partial credit. Show me work. All right, so what's y equal to?
Say that again.
What's y equal to? If x is equal to the square root of 2 over 2,
Y is the same thing.
y is exactly the same thing because y equals x. So this coordinate right here is the square root of 2 over 2, square root of 2 over 2. Which is nice because even if you screw it up, and I say, what's the sine of theta, sine of 45 in this idea, sine of pi over 4, what's the answer?
Square root of 2 over 2.
There's the cap.
Square root of 2 over 2. Because it's either or. You can't even screw it up here with the order. But it is the y coordinate. What's the cosine of pi over 4? Square root of 2 over 2. It's one of the only angles where cosine and sine agree on a value when they're equal to each other.
So if you have pi over 4 on a unit circle, the X and Y are always going to be the same.
Well, not exactly the same, but over here it would be square root of 2 over 2. Over here, one of them will be positive, the other one will be negative, so forth and so on. But the value will be square root of 2 over 2. All right, what about pi over 3? That's a special one. Oh, by the way, these are not the best ways of finding them, but with a unit circle, they're the only way.
Yeah.
Pi over 3 is 60 degrees.
So it's
So
So
you cut the quadrant into thirds, right? And then it would be the
yeah, I mean, you're basically right. Take a unit circle, cut the top into a perfect third,
which we can't do.
top half. It's going to be hard.
Yeah.
Here, close.
close enough.
I actually need it to look pretty good.
Challenging
There
stuff.
we go. So if this is pi over 3, and this is the line that's going through it, it's really hard to find the equation of this line, so we can't do it the other way. So we have to come up with another method. So if this point here is a comma b, this point down here is 1 comma 0, what's the coordinate of that point over there?
It's negative A, comma B.
Because it's symmetrical. So this would be negative a comma b. So far so good?
See,
All right. Since I don't know what color I'm working with nowadays. Since
It's a sine.
this is a chord of a circle, right?
Mm-hmm.
This is also a chord of a circle. What do you think is true about those two
they're
lines?
equal distance.
They have to be equidistant,
Equidistant.
or equal, or congruent,
Equidistant.
depending on how you want to phrase it. So the distance of this chord and the distance of this chord have to be exactly the same because these angles are exactly the same. So equal central angles give you equal chords. It's one of those geometry things. So how do I find the distance between,
Distance formula between the points.
let's go with these two first. What's the distance formula?
I forgot.
Distance is equal to the square root of the change in x squared plus the change in y squared.
I mean, at least I too.
What's the change mean? What do you do with the x coordinates?
You subtract it.
Change is always subtraction. So if I try to find the distance between these, it would be the square root of a minus 1 squared plus b squared is equal to the distance between these two would be what? Without even using distance formula.
Would they be the same thing?
Well, you could do the distance formula, but it's pointless. You're on a horizontal line. How do you find the distance?
You just count the units.
Yeah. So how far is it from AB to negative AB?
1, 2,
To,
A. 2 what?
what?
Is there a letter?
Oh, I swear. If you're on a horizontal line, and here's 0, and you're 4 this side and negative 4 that side, what's the distance between them?
8.
It's
8. So if this is A on one side and negative A on the other side, what's the distance between them?
8.
A, not 8. A, the letter A. So how did you get 8 out of 4 and negative 4?
So it's 2A. Am I right?
Okay, how do you get A out of 4 and negative 8? How do you get 8 out of 4 and negative 4?
Because it's 8 places.
Yeah, but how do you, using 4 and negative 4, how do you get the number 8?
They're that far from the center.
But how do you, what calculation are you doing?
Add.
No.
You're adding them? Really? 4 plus a negative 4.
It's going to be 0.
There's
Right. Say it.
Subtract.
You're subtracting it. What's 4 minus a negative 4?
It's a positive.
Positive
It's
4.
4 plus 4, which is 8. So what's A plus a negative A, minus a negative A? Oh, we should have just done the distance formula, been done with it. Distance formula. The square root of, what's the change in x?
Please let us go.
No, what's the change in x? What's the x coordinates for the top segment there?
Can you just say
A
plus A
plus A
squared
squared
plus
plus,
B minus B, which is going to be 0.
which is 0. Wait. What's A plus A?
2A,
What's 2A squared?
4A.
4A. We can get rid of the square roots, right?
Was I right?
What?
Was it 4A?
It's 4A.
Okay.
Can we get rid of the square roots?
Wait,
If this side is all square rooted and this
Yes.
side is all square rooted, we should drop the square roots. So this is
A minus 1.
A minus 1 squared plus B squared is equal to 4A. Pulling teeth.
I thought you said we
What?
could drop the square.
Square roots. If both sides are being square rooted, I can
Where,
drop.
where are you getting 4A?
Oh, okay, yeah.
I can't change the insides, but I can drop the square roots.
I got you.
A plus.
2, and then you get 4A.
A plus A is 2A. 2A squared is 4A.
Oh, 4A squared. I forgot the square.
Burn.
That's why I didn't know where you got it from because
Oh.
you forgot the square.
Yes.
Yes, that is it.
Alright, what's A minus 1 all squared? I love doing algebra because it reminds you that algebra is still part
That's
of
A
this.
squared minus 2A plus 1.
Plus B squared is equal to 4A squared.
I was right.
So far. Now here's the tricky part. What's A squared plus B squared? Now remember, AB is a coordinate on a unit circle.
That's 6 squared, isn't
AB is a coordinate on
Oh,
a
it's
unit
1.
circle. It's 1.
it?
Because x squared plus y squared equals
1.
1. So this becomes 1 minus 2a plus 1 equals 4a squared. Then
So
what?
you get 2 minus 2A equals 4A squared.
2 minus 2a equals 4a squared.
You want to move it to the other side.
So you get 4a squared plus 2a
Minus 2.
minus 2 equals 0.
And then factor it out.
Factor what out first?
B4.
2.
2. Never mind.
The only thing common is 2, so divide both sides by,
2.
and you get 2a squared plus
A
minus 1, 0.
And then factor.
Factor. What's a factor into?
I don't know.
You all forgot how to factor?
No, I didn't forget how to. I just.
Oh, well this one's
I don't
easy.
know what it is.
You have a 1 at the back, so this is 1, this is 1.
Okay.
You have a 2 in the front, so one of them is 2, the other one is 1.
Okay.
and it has to be A. Now all you have to do is figure out which sign goes where.
They're positive middle name, and so one's gotta be positive, one's gotta be negative, right?
So which one's positive, which one's negative?
The first
need
one's
a-
negative.
First one's negative. Yeah, I'll agree with that. And the second one
Yes.
is positive.
Yeah.
So when you solve this, you get A is a half, or A is -1. What's wrong with -1?
You can't have a negative.
If AB is located here, there's no way that the answer is -1. So the answer has to be
It's gotta be a half.
a half. So if A is equal to a half, how do you find B?
You plug it back
What?
in.
Into what?
The original.
That up there at the top.
Oh, God, no. Easier
Then you
formula.
would do it.
Go back to here. A squared plus B squared
Oh.
equals
1.
1.
So,
And this is A.
so 1/2, so
A
half
squared plus B squared is equal to 1. So 1/2 squared plus B squared is equal to 1.
A quarter.
A quarter.
Quarter
Plus-
B squared.
B squared is equal to 1.
So B squared is gonna be equal to 3/4.
3/4. So therefore B is equal to, without the plus or minus garbage,
Square root.
Square root of 3/2.
square root of 3/2. So this coordinate, this AB,
Is 1/2.
oops, AB, is equal to a half square root of 3/2.
Stop.
I will now.
That was all my answer.
Except for one thing, I just have to write the answer in. Therefore, the sine of, what is this, pi over 3. The sine of pi over 3, which coordinate is it?
It is what it is.
What's sine equal to? Is it the x coordinate or the y coordinate?
It's the one.
It's the y coordinate. It's alphabetical. Think about it. It's x, y, c, s.
Okay.
So it's alphabetical. So sine is the y coordinate, so this would be square root of 3/2. So the sine of pi over 3 is square root of 3/2. What's the cosine of pi over 3?
This is 1/2.
1/2.
Perfect.
Trigonometry the hard way. So when I show you the easy way, you're going to appreciate it.
Why didn't you show us these with the beginning?
Because I got to show you the hard way so you appreciate the easy way and you'll focus on the easy way. Now, there is one thing you do have to know. The only thing that'll give you 0, 90, 180, 270 is the unit circle. You can't do it the easy way.